The main role of biofiltration in fish or shrimp aquaculture is the treatment by uptake and conversion of toxic metabolites and pollutants. Bacteria biofilters oxidize ammonia to less toxic, while microalgae photosynthetically convert the dissolved inorganic nutrients into particulate nutrient packs that are still suspended in the water. Macroalgae, which is seaweed, sequester the nutrients out of the water, and finally the clean and oxygen-rich effluent of a seaweed biofilter can be circulated back to the fish pond or discharge. China and Korea are the example of countries that applied seaweed in their integrated aquaculture. Shanghai Bay in China is known to be the world's largest integrated multi-trophic aquaculture practice, while most Korean practices have conducted in small land-based systems. Shanghai Bay is one of the most important mariculture regions for scallop and kelp. The choice of seaweed species for inclusion in an integrated aquaculture system must meet a number of basic criteria such as high growth rate, easy to cultivate, high resistance to epiphytes, match between ecophysiological characteristics, local species, high market value, and finally influenced by intended application. But there are also few challenges. The first one is water currents and hydrodynamic forces. Both current strength and direction are important to determine nutrient and particle fluxes and thus the appropriate orientation of the different species within cultural unit. The importance of the latter can be visualized by considering an integrated scallop culture. If the direction of long line rope is not parallel to the direction of current, the kelp may become wrapped up in the scallop nets. This will reduce the scallop growth and loss of biomass due to entanglement. Next, nutrients and light are key environmental factors that determine growth rate and thus productivity of seaweeds. Ammonia, the main nitrogen compound that being excreted by fish, accelerates seaweed growth. Nitrogen usually limits primary production in coastal areas, and this limitation may be even more severe in offshore non-enriched waters. The third one is falling organisms and product quality. Nutrient manipulation have been shown to impact seaweed biomass yield, productivity, and epiphytic production. Next is the temperature. The temperature regime at the culture site should be carefully investigated to evaluate suitability for the growth of all the species within the system. Last but not least, the economic feasibility of offshore. The cost of the main input of intensive offshore culture of carnivorous fish, energy and feeds, as well as high construction, maintenance and transportation costs are increasing. There are no feed costs for extractive species, but there are other costs for infrastructure and operation to produce additional co-cultured species.
Despite the challenges, there are a lot of advantages in applying the seaweed in the integrated agriculture which contribute to the environment and also the economy. First, seaweed able to absorb dissolved inorganic nutrients such as phosphorus, nitrogen, and ammonia, which are excreted from the fish waste and also the fish feed. This will provide a clean environment for the fish to grow. Thus, the fish body size and body mass will also increase and will produce a high quality of fish which can meet the high demand from the consumers. Second, seaweed is also known as a great carbon dioxide takers and storage. Seaweed able to help to deacidify the seawater and at the same time able to fight the climate change. Third, as a coastal defense, this is because the seaweed able to reduce your hydrodynamic energy from the wave, which at the same time able to protect the aquatic animals from any injuries or any mechanical stress. In terms of economic value, applying seaweed in the integrated agriculture is a brilliant alternative to help to increase the fishers and breeders' income. This is because the plant-based food, which is seaweed, able to replace the fish meal. Second, they are able to reduce the workers' number, wage, and energy. Third, many aquatic animals can be grown within one site, such as abalone, oyster, and shellfish. However, in order to maintain the sustainability of this application for a long time, more types of seaweed need to be explored and studied, and the long-term effect of applying this application need to be studied too. Thus, fishers, researchers, public and private sectors need to work together to scale up this application to more regions. In conclusion, the application of seaweed in the integrated agriculture still have a long way to go. These applications have a high potential in saving the environment and economically beneficial. With that, thank you. With that, thank you. With that, thank you.